Okay, so this more or less going to be another problem we are going to try out. Problem says we have, okay, if P and Q are both prime numbers, and then the value of Q can be determined after we add 2 to P, then the pair 2, that's the P and the Q, are called twin primes. Now, an example was given that 5 and 7 are twin primes because the difference between them is 2. Devise a computer solution to list all twin primes less than a positive integer n. Basically, what this one means now is, yeah, a user is going to give us a particular n, or for every n given, then we are supposed to think of the n as a range where we are ending, and all twin primes within the range must be printed on the screen. I'm going to give an example and then we'll sort of understand. So over here, all right, so over here, I'm bringing in a new slide and I'm going to use this to illustrate. Imagine the user enters a number like 7, or let me do it gradually. User enters a number 5. The user enters a number 5, then the range is going to be 1, 2, 3, 4, 5. So if you are supposed to generate a list of numbers, then you will need to make sure that all the numbers you print on the screen must start from here, start from 1, and then end at 5. Any number you will print, no number should be out of range. Okay, so all twin primes within this range. But what's a twin prime from here? You can see that 3 over here is the prime of the number 5. So 3 and 5 are twin primes. Aside 3 and 5, if I'm supposed to continue with 6 or 7, that's if the user enters the number 7, then I can say that 5 and 7 are also twin primes. If the user did not enter 7, and the user entered something like 15, and I can say I have 8, 9, 10, 11, 12, 13, 14, 15. From here, 9 is not a twin prime. 9 is not a prime, so we can't say that from 7 we go to 9, hence no. Over here, 10 is not a prime, and so I wouldn't even use 10 as a basis to now check 2 numbers away from 10. 1 is not a prime, so if I say 1 is a prime, then I will say, okay, I'm adding 2 to 1 to now check whether 3 is a prime. But because 1 is not a prime, I don't do that. I check, is 2 a prime? 2 is a prime. 2 plus 2 gives me a 4. 2 plus 2 gives me a 4. And 4 is not a prime. So basically, even though we have 2 being a prime, we cannot say 2 and 4 are twin primes. 3 is a prime. Okay, 3 is a prime. Now 3 plus 2 gives us the value 5. And 5 is also a prime. The 2 over here is the one that was given in the question. So if P is a prime, then adding 2 to P, we get a Q. So this is a prime. So we can conclude that, okay, 3 and 5 are twin primes. Then we go on to 4. Is 4 a prime? No, 4 is not a prime. So because 4 is not a prime, I wouldn't even bother adding 2 to 4 to now check. But when we proceed, you know how we proceed. We call the step if we are using the for loop. When we proceed, we have the number 5. 5 is a prime. It's when I add 2 to 5, will I get a number that is that's also a prime? and the number I get is 7. And 7 is a prime, except they change it. And no one is going to say 7 will not be a prime. 7 is a prime. So 5 and 7 are twin primes. Alright. Had the user given me a value 7, I would have ended my code here. In that case, it was on a particular I, or let me say, a particular time the control variable got to I. That was where I ended. Because whatever I'm supposed to print should be within the range. I shouldn't say, because the user said 7, I'll wait till I get to 7 and then add 7 plus 2 to get whichever number. No. I need to end 2 meters. Let me use meters for you understand. I need to end 2 numbers away from the end of where the user talked about. Now, let me try it till we get to the 15. All these are not primes, so you let me skip them and then come to this side. Now, okay, let's talk about it. 7. 7 is the next prime number. So over here, the 7 plus 2 is equal to 9. And 9 is not a prime, so I don't even include this at all. Let me look for the next prime number, which is 11. So having 11 plus 2 is equal to what? 13. And 13 is a prime number. So I'm going to say 11 and 13 are prime numbers. We don't have any other prime again for me to now jump to be comparing. So basically, this is the concept of the twin prime. Okay, what you need is you need a sequence of numbers, and the only way for you to get the sequence of numbers or the series of numbers is for you to use a loop, because the values in a loop change all the time. Anytime you get a new value inside the loop, then the first thing that you will have to do is check whether that new value that has come is a prime or not. Okay, and then when you do, then you continue. So I have some clues over here to help you when you get a question like this. First, we need to understand where we'll be getting the numbers. The user told us all the things we are supposed to print on the screen should be within a range. And usually the range we start from 1. So should be within 1 and then a particular end that he's going to enter. But we're given a formula which was dealing with a particular plus 2. So if anything at all we are supposed to print is supposed to be within a range, then we should take note of the plus 2. Now, anytime you think of generating a series of numbers, you need a loop. I've always been saying this. Now, the next one is how are we going to generate the numbers? There are some steps we need to follow. So, get yourself a control structure that splits the numbers. And that control structure is going to be a loop, because the loop's control variable, when I say control variable, you know what I'm talking about. Control variable changes each time you will have access to the new value only in the loop. When I say the loop, I mean the loop you created over here. So I'm going to give an example over here, and then you will understand what I'm saying. If I have 4, I equals 1, 2, let's say 20. Step 1. What happens in this case is I can decide to print I, and then I'll end my 4. The statement above, what I've declared, what I've said over here is get yourself a control structure that splits the numbers. These control structures, this particular control structure, the 4 for I equal whatever, is the one that's going to generate the numbers for us. When it generates the numbers for us, how will we have access to the numbers? It shouldn't keep the numbers in a container or anything of that sort. There are some things we want to do with the numbers as they come. Sorry, as they come. So we can only have access to the ever-changing numbers from here. So we need to write our code inside the loop to be able to do something with whichever number that's coming. And that's how come we had to enter this particular part. So in this case, I can say print I anytime the I comes, and then they are going to have it printed on screen. So basically, the prime number issue, what we need to do is we need to generate a particular loop that runs from the n that the user gave minus 2. I say minus 2 because the moment we get to an n, we'll have to, the moment we get to a particular I, we have to add 2. We have to add 2. And the question said that whatever we are printing on screen should be within the range of whatever the user entered. So the value of n, the last value of n that I'll have to add 2 to get the number the user entered is basically n minus 2. The only way I can cure this is if I have n minus 2 and I add 2, basically I'll end at the limit of n that the user gave us. The user said we shouldn't print anything more than n. So n minus 2 plus 2 basically make sure that we end at n. That's the explanation. So if we get a loop, this is not how I'm solving it, but more or less like we are trying to find a way out. So if I get a loop that runs from 1 to n minus 2, I know that I'm going to have the value of I changing all the time. So when the value of I comes, I'll be checking some conditions. Okay, so that's basically it. So I'll first have to check whether the coming number is a prime or not. If it is, then I will add 2 to the number, like in expression q equals p plus 2, given that p is prime. If q is also prime, then I will print both numbers and call them twin primes. That's basically it. So let me create a new slide, and then I have some clues over here, but I think I've explained it. So let's start with the solution. Now there's a number, right? The first thing we'll have to do is to get the generation, the numbers that we want to check whether they are primes or not. And then now from there, we are going to check whether the number is a prime. And if it's a prime, we will add 2 to the number, and then we will, because you've seen if here, I'm going to have to do a check. And then there's another if here. But take note of how they are nested. When we start, you get me. So the user is supposed to first give us a number. Okay, so the user inputs a number. Okay, and the user inputs a number. Then the next thing that's going to happen is, I've already explained where we are going to end. You can use a while loop if you want, but I like going with. So the P is what we are going to be checking. So we are going to say for P equals 1 to n minus 1. Now if you have it this way, you come to the next line, and then because you know that the value of P is going to change all the n minus 2, sorry, I'm moving from 1 to whichever number. Because we know that the value of P is going to be changing all the time. That's the step 1. what we will now do is anytime we get a new p, what I want to do is to check whether the p is a prime or not. And before I get to know whether p is prime or not, I need a variable set to 0. So I'm calling this p factors, right? If I set this variable to 0, then I can write the code that will help me to know whether p is a prime or not. For you to know whether a number is a prime or not, you need to find out the number of factors of the number. So I put this particular initialization, p factors equals 0, because I know that different numbers are going to be coming anytime the loop runs. So if I set p factors equals 0, then what's going to happen is every new p now will come, whether p is 1, p is 2, p is 3, is going to have a number of factors to be 0 before I now check it over here. So I'm going to have a dummy variable over here called I, and that I is going to be running from 1 to a number less than the value of p, or from 1 to p. Basically, let's stick with this. So that one too will have its own step 1. And then inside this loop, what I'll check is I'll check whether the value of I that is coming inside here is going to be able to divide p without leaving a remainder. So that's basically how we write it. If you don't understand this, go and watch the video on modulus. And then if this condition is met, what I'm going to do is to increase the value of p factors. The p factors is supposed to be increased by 1. And when it is increased by 1, I end the if. Okay, when I end the if, I'll have to end the for, because I'm basically done with whatever I'm doing inside the for loop. At the end of this for loop runs from 1 to p. At the end of this for loop, I would have gotten the change that I want to happen inside the p factors. So p factors will definitely have a value after this. So in this case, I can check whether the p factors that I have here was able to change right at all. If it was able to change, then its value might have gone up. So I want to check whether the value, the number of factors of p, the current p that we are on right now, since 1 starts from 1, then the current p will be 1. I want to check whether the number of factors is equal to 2. If it's equal to 2, I have a condition I want to be checking. If it's equal to 2, I need to get a new number called q. And that q is supposed to be this. If the number of factors is equal to 2, what it means is that p is a prime. If this modulus I equals 0, it means that this is a factor, the I is a factor of the p. So take note of that. Some of the things I wouldn't be touching on. And then, wow, the thing is reducing in size. So we are going to go to the next slide. So take note of wherever we've gotten to. Insert another slide. So over here, this is where we are. And then the continuation is still supposed to be under the loop. So try and then get that clear. Okay. I try to make the reserved words capital so that doesn't confuse anyone. So in this case, we have q is equal to p plus 2. Still inside the if condition. What I now want to do is I want to check whether q is a prime number. So by checking, I need to get something that will be storing the number of factors of q before I start the checking. So I set the number of factors of q to 0. Take note of something over here. I'm going to enter a loop. And so that is how come I decided to now set the number of factors of q equal to 0 outside the loop. If I bring it inside the loop, anytime we get the value of x over here changing, what is going to happen is they are going to set number of factors to 0 each time, and I wouldn't want it that way. That's how come. And you wouldn't want it that way. So basically, it's not only me. If you have a question, you can send it to me through mail or something, and then we'll get to know. If I want to check whether the value of x over here can divide the q without leaving a remainder. When I say without leaving a remainder, basically what I'm trying to say is I want to know whether the remainder is going to be 0. Okay, so let me bolden this so you see it clearly. Forget about the red squiggly line. It's not really important. It's Microsoft Word doing this thing. So if it's equal to 0 now, it means that it's a factor. It's a factor of q. So all I'm going to do is to increase the value of the q factors, right? And I'll end if. When I end my if, I'm done with whatever I'm doing in the for loop, so I'm going to end the for as well. Now, we are still inside the for loop, and then we've been able to get the number of factors of q after writing this particular code, q factors. So what I want to do now is to have another condition that checks to see if q is a prime. If that condition now executes true, then I'm going to say that now for us to know whether q is a prime, we will just check q factors equal 2. If this is true, then what I would want to do now is to print p comma q. We are inside the first for loop, the outer one, so we have access to the p comma q comma are twin primes. Basically, that's the end. And then I end my if. When I end my if, I should end my for. The if over here is inside another if, so I have to end that outer if too. If you wrote it, you might have seen it. But since you are waiting for me to write it, then so this is basically where we end. So this is the if that we are in that I had to end first. Immediately I ended this. This is the if, okay. And now we are inside another for loop, so I had to end the for loop too. And then this is the end of the code, right? All right, we are done then. Stay tuned for the next